Hello, my name is Chloe Reed and today I'll be presenting Biomechanics 7.1, a linear motion. What is biomechanics? Biomechanics can be split into two root words, bio and mechanics. The root bio relates to the physical side of sport, whereas the root mechanics relates to the movement of sport. Biomechanics is defined as the mechanics of human movement. Why is biomechanics important during sport? There are two main reasons for this. Number one, it helps improve their performance by analysing their movements. This allows the athlete to see their progress, allowing them to analyse what their strengths and weaknesses are. This will help them with intrinsic feedback during a game, which will significantly help improve their performance. Number two, it can also help prevent injury. This is important as it means the athlete will be continuing playing sport, which will allow them to improve on their skills and refine their techniques. This would be extremely beneficial for the athlete's mental and physical health. Motion. Within the sport environment, motion is everything, as understanding motion is essential to improve performance and help understand how a player could execute a skill. Motion is defined as a change in position of a body with time. The movements during sport need to be efficient so the athlete can perform the skill to the best possible standard. Effective motion allows the athlete to be sufficient in movements. During a game situation, this will allow the athlete to have a greater chance of winning or gaining the most points. For example, a jump shot during basketball. This player would begin the position with their legs shoulder width apart while also bending their knees by contracting their hamstrings, which is the agonist of knee flexion. When they jump, this position would allow the player to gain sufficient power for the shot as their quadricep would quickly contract as it is the agonist of knee extension, quickly pulling the leg straight. While this is happening, when the player begins to jump, the gastric knee muscle would simultaneously contract to make the ankle plantar flex. Both the quadriceps and gastric knee muscles contracting would generate sufficient power for the athlete to gain maximal height, which therefore would give them a greater chance of making the shot. Kinematics is also a part of motion. It describes the forces that cause motion. The key concepts of this include displacement, velocity, and acceleration. Kinematics is applied during sport to analyse and improve athletic performance. Some ways this is used during sport is the technique analysis, performance optimization, and injury prevention. Types of motion. There are three main types of motion: linear motion, angular motion, and general motion. Linear motion is not common in sport, however it can be split into two sections: rectilinear and curvilinear. Rectilinear is defined as a motion along a straight line. An example of this is a bowling ball in a straight line. As the athlete brings the bowling ball towards their body, their elbow would perform flexion as the bicep would be contracting. As their shoulder performs extension at the same time, the posterior deltoids would also contract. This allows the bowler to gain sufficient power to throw the ball. As the ball is thrown, the shoulder would perform flexion. This would help the ball move in a straight line. Curvilinear motion is defined as a movement along a curved line. An example of this is a runner sprinting around a 200-meter bend of a race. For example, Usain Bolt. When Usain Bolt runs along 200 meter, he has to perform flexion and extension sufficiently to gain the most power and speed. This would give him the best chance of winning the race. Usain Bolt's 200-meter splits were 0 to 100 meters was 9.92 seconds, and 100 to 200 meters was 9.27 seconds at his world record. There are two other types of motion: angular motion and general motion. When linear and angular motion are combined, they equal general motion. Angular motion and general motion. Angular motion is defined as a movement around an imaginary or real axis, with all body parts moving through the same angle in the same direction at the same time. A main example of angular motion is a hammer throw, as the athlete rotates on a longitudinal axis to create power on the throw, which allows them to have a greater chance of placing first. When the hammer is thrown by the athlete must lower their body to produce sufficient force against the ground during the spin to propel the body and the hammer. This movement involves eccentric contractions in the legs during the wind-up and then powerful concentric contractions during the final rotation and release. The hamstring, when spinning, will slowly get longer as the athlete begins to release, and when the release occurs, the quadricep will quickly contract, causing a powerful concentric movement. Once the hammer is in motion, it has angular motion, as it depends on the velocity of the spin and the radius. If there is a longer radius, there will be more angular momentum created. Another example of angular motion is a gymnast performing a somersault, as their body rotates around an imaginary axis through the center of gravity. As mentioned before, general motion is a combination of linear motion and angular motion. Almost all movements during sport fall within this category. An example of general motion is swimming, cycling, and running. Moreover, a triathlon. It involves both linear and angular motions. Linear motions can be seen in the swimming and running part of this triathlon, and angular motion can be seen in the cycling duration. Mass. Mass mostly affects sport performance due to its relationship with force and acceleration. Mass affects speed. An example of mass in sport is a football. The average football has a mass of 0.45 kilograms. If mass changes for each game of football, then this would mean each game would become unreliable. It is important that mass of the football stays the same, as it means the players can train to be more consistent within the game. Mass can be calculated by multiplying density and volume. The units of mass are kilograms, and it is a scalar quantity. An example of when mass is applied during sport to a person is in rugby. If a rugby player has a larger mass, then they will generate more momentum, therefore making them harder to stop. This would give the team a bigger advantage, as it would be harder for the other team to stop them running at a high speed. Inertia also plays a role when it comes to mass being applied during sport. During athletics, heavier objects, for example a shot put, are harder to accelerate. However, they can maintain acceleration better once in motion. This is why younger athletes usually have lighter objects. For example, an under-11s football team will have the ball with a lighter mass, as they will not have much muscle mass themselves, so it can be hard for them to kick, throw, or control the ball. So therefore, having a lighter ball will help with participation rates and make it easier for them to learn the skill. Weight. Weight is defined as a force exerted on the mass of a body by gravitational pull. Weight is measured in newtons, and you can calculate weight by multiplying mass and gravitational field strength. An example of weight in sport is weightlifters. Heavier athletes can push and throw heavier objects, therefore someone heavier would be better suited to powerlifting, as they would be able to generate more power. Heavier athletes might have an advantage during lifting, as they would have more significant muscle mass, and they would also have more stability when lifting heavy weights. Heavier athletes have an advantage during sport, as they have a greater body mass, which will mean they would be more physical during a tackle. For example, rugby. On the other hand, generally, lighter athletes are faster, as their body weight is lower, so they can be more agile and their weight won't slow them down. Normally, sprinters are lighter, as they have to be able to bounce off the ground to generate power efficiently. In basketball, agility is key. Lighter players can change direction quicker, so this would give them advantage against an opponent who might be heavier. Weight can be calculated by multiplying mass and gravitational field strength. Vectors. Vectors are defined as a quantity that both has direction and magnitude. A vector must have direction. Examples of direction that can be used is up, down, positive, negative, north, east, south, and west. It can be calculated by its magnitude and considered displacement of a body or an object. Key terms of vector quantities include displacement, which is defined as a straight line that an object has to travel on to get from the start to a finish. Velocity, which is defined on how quick an object can move at a certain speed in a certain direction. Acceleration, which is defined as the rate of change of velocity, deceleration, which is defined as reduced acceleration or negative acceleration, weight, which can be defined as force exerted on objects by gravitational pull of the Earth, and momentum, a quantity of motion of a moving body which can be measured by multiplying mass and velocity. An example of a vector being applied during sport is a sprinter in a specific direction at a certain speed. The speed the sprinter runs at is velocity, while the vector determines the direction. Another example of a vector is displacement. If a cyclist was cycling around a park, the displacement would be how fast the athlete could travel from the start to the finish, the most efficient way. A final example of vector is weight. Scalar. A scalar is defined as a quantity of only having magnitude and not direction. It is also measured in magnitude. Key terms of scalar quantities are distance, defined as the sum of all movement, speed, how quickly a body can move, mass, the amount of matter in an object, and inertia, the resistance of an object to a change in its state of motion. Unlike vectors, scalars are simpler, as they do not need direction when something occurs. An example of scalar during sport is a runner. The scalar is the distance they cover and not the direction they ran. These measurements allow the coach to measure speed or how much time an athlete spends in different phases of competition. Going back to the example from earlier, Usain Bolt, his coaches would either do 100-meter splits or 50-meter splits. Scalars are very useful for setting goals and in tracking a progress of an athlete. Another example of scalar is mass, as it is the distance covered, not where it goes. My bibliography.